welcome. Today we are going to explore one of the most powerful tools in mathematics, the Laplace Transform. So get ready as we dive into this fascinating concept. Let's begin the journey. The Laplace Transform of a function ft is defined as an integral transformation. It is given by. Here the function ft is transformed into a new function of s, which is a complex variable. This transformation is incredibly useful as it converts functions from the time domain to the s-domain, making equation solving much easier. The Laplace transform of the 1 begins by substituting the function ft equals 1 into the integral definition. Now let's evaluate it step by step. The integral of e minus f2 is calculated and we apply the limits. At infinity, e minus s2 approaches 0, and at t equals 0, it evaluates to 1. Thus, the Laplace transform of 1 is simply 1 over s2. The Laplace transform of e power at begins by substituting the function lf of t equal to e power at tau into the integral definition. Next, we compute the following integral and simplify the expression. Thus, the Laplace transform of this exponential function is the 1 over s minus a, valid for s greater than a. The Laplace transform of t power n can be calculated using the well-known property of the gamma function, and the Laplace transformation is equal to factorial n over s power n plus 1. Must remember the definition of the gamma function. The Laplace transform of sine of t can be calculated by evaluating the well-known and very popular integral. Applying the limits, we get the Laplace transformation as over s squared plus s squared, valid for s greater than 0. Similarly, the Laplace transform of cos at can be calculated, and we get the Laplace transformation as s upon s squared plus a squared, valid for s greater than 0. Here, to evaluate the Laplace transformation of sine hyperbolic at, substitute the expression of hyperbolic sine in the form of iota, and simplifying it, we got the transformation as a upon s squared minus a squared, valid for s greater than mod a. Similarly, for cos hyperbolic at, following the same approach, we obtain the Laplace transformation as ss upon s squared minus a squared, valid for s greater than mod a. Practice time. To strengthen your understanding, here are some practice problems for you. Solve them and drop your answers in the comments below. If you found this helpful, don't forget to like, share and subscribe for more math insights. See you in the next one. Until then, keep learning and keep exploring.